All right, so let's begin with the units and dimensions, the first chapter. So now we know, of course, we know what is a quantity. What's a quantity? Anything which can be measured is a quantity. Okay, so we are going to talk about the measurements, right? Units, dimensions, measurements. So quantity is anything that can be measured. For example, 10 apples, okay, 5 kg sugar, etc. The number of students in this class, okay, 1 2 3 4, anything, right? Or number of girls in your class, number of boys in your class, that is a quantity. Okay, so then next is physical quantity. What is a physical quantity? The quantity which is related with the properties of matter, okay, property of material or a system, that can be measured. So that property should be able to or that thing should be able to we should be able to measure that. Okay, for example, length, mass, time, force, etc. These are physical quantities. Okay, so then anything we measure has a unit. Okay, so what's a unit? Unit is a reference standard for measurement. So this is standard definition. Unit is arbitrarily chosen and internationally accepted reference standard for measurement. So for example, suppose you want to measure my length. My length means my height you want to measure. Okay, and you don't have anything else. Suppose you are handed up with this pen. I give you this pen, and then you measure my length. Suppose 1 2 3 4 5 6 11 pens. Suppose that's my height. So what will be the unit? Unit will be the length of this pen. Okay, so height of snail sir is 11 pens. But then this is not an accepted unit, right? Because I have this pen, I can hand it over to you. Okay, though this is virtual conference, but everybody will not have this pen, the same pen, right? So it is very difficult for the acceptance of this unit. So the unit should be such which is available everywhere, right? It should be available, easily available. Okay, and it should be accepted everywhere. Okay, so these are requirements of standard. It should be invariable with place and time. Okay, it should not change from this place to that place, and it should be easily available and easily reproducible also. Okay, because if you make, for example, you make 1 kg weight, okay, you should be able to make thousands of those, because you want to distribute them, okay, for measurement in each and every part of the world. So that's why it should be easily available and reproducible also, right? So now different parts of world had different systems of units, and the most widely used were FPS, CGS and MKS. So now what is system of unit? So earlier there were only 3 quantities studied in physics. 3 quantities means only one subject called as mechanics, then the thermodynamics, the electricity, magnetism, etc. It was added later. Then there is modern physics, it was added later. If you talk about 16th century, there was only one subject, that is motion, mechanics. Okay, so any quantity in mechanics you can represent using length, mass and time. So if you have unit of those 3 things, you have system of units, and that's why these were the system of units. FPS was used in some part, okay, then CGS was used in some part, and MKS was used in some part. Okay, so what is FPS? So in FPS system, the unit of length is foot, unit of mass is pound, unit of time is second. Okay, that's FPS. In CGS, unit of length is centimeter, unit of mass is gram, and unit of time is second again. And in MKS system, the unit of length is meter, unit of mass is kg, and unit of time is second. Okay, so these were used in different parts of the world, right? Because for example, suppose there is a country, okay, or there is a kingdom, right? Then they will make their units depending on their convenience, right? Based on their convenience. Okay, so there is a story, how did this FPS system, not FPS system, this foot came into practice. There was one king and he just announced that the unit of length in our country, in my kingdom, from tomorrow it will be my foot. That's it. Okay, and then it became the unit of length. I don't know how true it is because foot is a little bit big, right? Okay, anyways, so these are systems of units. Out of this, the important one is MKS, because now this one is internationally accepted. Okay, so see, if there are different systems of units and you know only about them, you don't know about the conversion factor, then what will happen? Suppose in your country CGS system is used and you talk with somebody where the MKS system is used. Okay, you don't know about MKS, that person doesn't know about the CGS. Then what will happen? If you are talking about anything, any scientific discovery suppose, or let alone scientific discovery, you are talking about your NEET problem, right? NEET physics problem. Okay, then you won't understand what that person is talking and he won't understand what you are saying, right? That's why there should be one internationally accepted system. Okay, and that is known as SI system. Okay, so what is a SI system? So in SI system there are some fundamental quantities and their units are fixed, and based upon those units of all other quantities are derived. Okay, and this thing is known, this thing is internationally accepted. Okay, this thing is internationally accepted. So what are fundamental quantities? The quantities which are defined through measurement. Okay, these are quantities which are defined through measurement, right? And they don't depend upon any other physical quantity for their measurements. So their units are predefined. Their units are defined I'm sorry, based upon their units, the units of other quantities are defined. This thing is clear, everyone? Okay, so they are known as fundamental quantities. For an example, length is a fundamental quantity. To measure length of something, you don't need to know about what's the time, right? What time it is right now. So length doesn't depend on whether it's morning, whether it's evening. Okay, so this is the fundamental quantity, right? This is very basic, but this is fundamental quantity, right? What is derived quantity? For an example, if you want to measure velocity, okay, how will you measure velocity of something? So some body is traveling and you want to measure its velocity, then you need to measure the length, distance covered by that body, right? And also the time, because the velocity will be what? Displacement, to be particular, displacement divided by time. So you need to know about length, you need to know about the time. So you need to know two quantities at least. So these quantities, derived quantities, they depend upon two or more, okay, two or more fundamental quantities for their measurement, right? Actually it's one or more, because there are few derived quantities. For an example, area. If you want to measure area, then what do you need? You need length and breadth. So you can say some power of length. Area will depend on some power of length, right? So you can say one or more. They depend on one or more physical quantities for their fundamental quantities for their measurement. This is clear? All right, good. Okay, so now let's look at the SI system. So what are the fundamental quantities in SI system? So mass, length, time, electric current, temperature, the amount of substance and luminous intensity, these are the fundamental quantities. Okay, so the symbols for them is mass is denoted by small m, length is denoted by small l, okay, time is denoted by small t, that's small t, right? Then current is denoted by capital I, temperature is denoted by capital T. Then amount of substance, you know that from chemistry, right? It is denoted by small n. that is number of moles. Okay, that is quantity of a substance, amount of substance. It's denoted by number of moles. And then there is luminous intensity. It is denoted by IV. Okay, or I nu. Okay, so then what are their units? So units are, unit of mass is kg, kilogram. The unit of length is meter in SI units. Okay, unit of time is second. Then unit of current is ampere. Unit of temperature is Kelvin. Okay, then the unit of amount of substance is mole, and unit of luminous intensity is candela. Okay, and their short forms are these: kg for kilogram, m for meter, s for second, a for ampere, then k for Kelvin, mol for mole, okay, and cd for candela, right? Then you can notice that here some units are written in small case letters, okay, lowercase, and some are written in capital letters. So what could be the difference? Can you tell me? Okay, so the difference is this ampere is name of a scientist. Okay, Kelvin is also name of a scientist. So if unit is given after somebody's name, then its symbol is written in capital form. Okay, because we write names starting with capital letters, right? That's why. And the full name of a unit, it's always written in lowercase letters only. Okay, this is clear. This is just a rule. Okay, so there might be a question, pinpoint question like this. I don't know, there was never. Okay, all right, so these are 7 fundamental quantities. Then now these 7 fundamental quantities only are not enough. We need 2 more quantities, but they cannot be called as fundamental quantities because they depend on the fundamental quantities, but to measure lot of other quantities we require them. That's why they are known as supplementary quantities. And what are they? One is plane angle, the other one is solid angle. Okay, so what is plane angle? Plane angle is the angle that we know about from our childhood, right? It's 2 lines like this. Okay, 2 lines kept, 2 lines intersecting at a point, or 2 lines starting at a point. Okay, this structure is known as plane angle, right? So that's plane angle. So how do we measure that? So there is a SI system of units. In SI system of units, what we do is, suppose this is a circle and this much arc of a circle makes an angle theta at the center, right? That means if you join end points of this arc at the center, you get this angle theta. Okay, so this angle is measured as length of this arc divided by the radius. Angle is measured as arc length divided by the radius, right? And this is in terms of, or in multiples of radius. That's why the unit is radians. Okay, the unit is called as radians. In short form, it's written as RAD, or its symbol is RAD. This thing is clear, everyone? Okay, good. Then what is the maximum angle an arc of a circle can make at the center? That's 2 pi. Right, we had seen this earlier in the first lecture. Okay, why is it so? Because maximum arc length is equal to 2 pi r. If you divide that by r, radius, then that r gets cancelled out, and therefore maximum angle subtended by any arc of a circle is equal to 2 pi. That's simple, right? 2 pi radians, and that is 360 in degrees. All right, next one is the solid angle. So the plane angle is the one which you can draw on a plane, right? Plane means a flat surface, you can draw that angle on a flat surface. Okay, so this is angle in 2D, 2 dimensions. Why 2D? Because to draw any flat surface, to think about any flat surface, you need x-axis and y-axis, right? You need 2 axes, so that is 2 dimensions. Okay, so then if you think about 3D, 3 dimensions, then you will get a solid object. You get solid objects in 3D. So next is solid angle. What is solid angle? It's angle in 3 dimensions. Okay, and now to think about solid angle. How will you get solid angle? So you take, for an example, you take this angle like this, and you just rotate. You keep this point, okay, the vertex of angle as it is, and you rotate it like this. So what will you get if you rotate an angle by 360 degrees? Think about the shape that you are getting. You get a cone like this, right? So that cone is called as 3D angle. Good, very good. You get a cone. Okay, so that cone is called as 3D angle. Now the question is how to measure that. So to measure the plane angle, we took help of a circle. Here we take help of a sphere. Okay, now this thing will look like a circle only because this is 2D paper, or not a paper, 2D tab, right? But this is a sphere. Okay, this is 3D. This is a sphere. Okay, so then here you take some area, small area, large area, any area on the sphere, and you join each and every boundary point of that area at the center. What do you get? You will get a cone, right? If you take some area, join each and every boundary point of that area to the center, you get a cone, and that thing is known as the solid angle. Okay, and how do we measure that? So it is the perpendicular area by r square. So now here you don't need to think about whether this area is perpendicular or not, because it will be perpendicular. Okay, so radius is always perpendicular to what? The circumference. So in the same way, this radius of a sphere will be always perpendicular to the surface area. Okay, small surface area of a sphere, radius will be always perpendicular, right? So perpendicular area is this one, dA is perpendicular area, and its distance from the center is what? R. Then the solid angle is denoted by this letter d omega. Okay, small solid angle, sorry. So d omega is equal to what? dA divided by r square. This thing is clear? Okay?
Yes, sir.
Good. Then this letter is known as omega. Then the unit of solid angle measured this way is T radians. Okay, the unit is T radians, and in short form it's written, okay, ST/rad, and most of the times in our textbook etc it's written this way, SR for steradian, right? Then the maximum solid angle, just like we saw the maximum plane angle, the maximum solid angle made by any surface, not just a sphere, a surface which encloses a point, so that surface will subtend maximum of solid angle equal to 4 pi. How is it so? So you have a sphere, suppose, then you just take for omega max, the maximum solid angle, whole surface area of a sphere, that is 4 pi r square, you divide that by r square gets cancelled out, and the maximum solid angle that you get is 4 pi, right? Okay, good. Next, let's see dimensions. Okay. So now we saw that there are 7 fundamental quantities and 2 supplementary quantities in SI system. So there should be a way to connect these quantities with the derived quantities. Okay, so that way is dimensions. So what is the dimension? It's the power to which the fundamental quantity has to be raised in order to get a derived quantity. The power to which fundamental quantity or quantities have to be raised to get the formula for derived quantity is known as dimension. So it is the relation between fundamental quantities and derived quantities. Okay, so let's come to this first quantity, that is area. So area can be written as what? Now area can be written as length times breadth. Okay, if you talk about a rectangle, then what will be its dimension? So dimension of an area is just equal to dimension of length, right, times breadth is also length. Okay, so we write this quantity like this, okay, in capital letter. So it is L times L, means it is just L square. Okay, it is just L square. So we put that in a box, right? Then similarly, what would be dimensions of volume? So if you think about any formula of volume, the length will come thrice, and that's why its dimensions are L raised to 3, right? Then next is velocity. What is velocity? Displacement divided by time. So that means velocity is length by time. Okay, displacement is length. Okay, d by t. Okay, so what would be dimensions of velocity? Its length in the numerator, time in the denominator. We write that by capital letters. Take the time in numerator. So here it is t raised to 1. In numerator it becomes t raised to minus 1, and that's why the dimensions are L1 t raised to minus 1, right? Next is acceleration. Similarly, you can say acceleration is change in velocity divided by time. So in numerator you have velocity or change in velocity. The unit will be equal to meter per second. That means it is length by time. Okay, so dimensions of numerator are L1 t minus 1, and in denominator you have one more time, okay, t. You take that to numerator, it becomes t raised to minus 1. So you already had L1 t minus 1, and this t minus 1 adds to it, so it becomes what? Dimensions of acceleration are L1 t minus 2, right? That's simple. Okay, next is force. So we know the formula of force is mass times acceleration. So what are dimensions of force? Dimensions of force, dimensions of mass, okay, m1. Then dimensions of acceleration we just found, L1 t raised to minus 2. So these are dimensions of force. And then you have energy or work, right? Work and energy are same thing. So the dimensions of that are dimensions of force times displacement, because work done is force into displacement. So you have dimensions of force already, m1 L1 t minus 2. Okay, and dimensions of displacement, this is not second, this is distance, displacement, that is L raised to 1. So therefore you have m raised to 1, L raised to 2, t raised to minus 2, m1 L2 t minus 2. So this is the way in which we can find out dimensions, right? So now why did I find out dimensions of these quantities? Because dimensions of these quantities, they have to be remembered. You need to by heart them. Okay, 12 o'clock in the night, or suppose you are asleep. Okay, you are in sleep. Okay, deep sleep, and somebody asks you what are dimensions of force. You should tell m1 L1 t minus 2, right? Okay, that much by hearted it should be, right? Then you should know the formula connecting these quantities and every other physical quantity that comes in physics. Okay, so that you would be able to find out the dimension of that quantity. Okay, all right. So for an example, find the dimensions of universal gravitational constant. So where does it come? So we have Newton's law of gravity, the force between two masses. So suppose this is one particle or one body has mass m1, there is another body which has mass m2, and they are separated by some distance. They are separated by distance r. Then Newton told us that the force between them is given by the universal gravitational constant multiplied by m1 m2 divided by r square. And therefore now we have the formula connecting force and universal gravitational constant. So we can find out dimensions of universal gravitational constant very easily. Dimensions of G would be equal to what? Just equal to, okay, for that we can write G is equal to F times R square, right? This R square will go on this side in numerator, m1 m2 will go in denominator because we want G only. So G is equal to Fr square divided by m1 m2. So the dimensions are dimensions of force times dimensions of distance square, that is L2, divided by, this is mass times mass, means m to the power 2. Okay, right. So then you have dimensions of G equal to, for force it is m1 L1 T minus 2 multiplied by, you have L raised to 2, and in denominator you have m raised to 2. So this m raised to 1 and the square gets cancelled out, so 1 will remain there. You move that m raised to 1 in numerator, so it becomes m raised to minus 1. So the dimensions finally are m raised to minus 1, L raised to 1 plus 2, that is L raised to 3, and T raised to minus 2. These are dimensions of universal gravitational constant. This thing is clear, everyone? Okay, good, very good. All right, so now that we know how to find out dimensions, let's see applications of dimensions. What are applications of dimensions? So first application is to check if the given relation is correct. So not only given relation, suppose someday you are so much interested in physics that this should not happen, I'm just saying it. You leave your medical field, start studying physics, okay, and not just that, you come up with some discovery like Newton, okay. So you will have some formula, no? Now you want to check whether that formula is correct or not. So first thing that you will do before presenting it to other people is you will check it dimensionally, whether it makes sense or not, whether it is correct dimensionally or not. Okay, so that will not happen, right? But anyways, so let's see how. So suppose you have this equation, S is equal to ut plus half at square. This is a kinematic equation of motion, and I'm sure most of you know this. S is equal to ut plus half at square, right? So now in this equation there are three terms. One is on left hand side, two are there on right hand side. So the dimensions of all the terms, okay, dimensions of all the terms in an equation should be equal, they should be same, then only it will be correct. It could be correct, right? I will explain why I'm saying it could be correct and I'm not saying it will be correct, okay. So see, but if dimensions are not matching, it will be definitely wrong, right? You can check it very easily. S is the displacement, that means dimensions are L raised to 1. Then you have ut, okay, u is initial velocity, t is time. So what will be the dimensions of this? Dimensions of u is the velocity, are L1 t minus 1, and dimensions of time is t1. So t minus 1 plus 1 gets cancelled out, that is t raised to 0. T raised to 0 means it's 1, okay, or constant which doesn't have a dimension, right? So you have L raised to 1. Constant means what? Numerical constant, okay. Only numerical constants don't have dimensions, otherwise we had one constant here, right? There are too many constants. Universal gravitational constant is a constant, but it has dimensions. Numerical constant means a number, just a number, Okay, numbers don't have dimensions, right? Keep that in mind. Okay, so we check that dimensions of this one and this one are same. Then 80 square, so half will not have any dimensions. Okay, so 80 square, a is acceleration, then you have t square. What are dimensions of acceleration? We just found it is L1 t minus 2. So L1 t minus 2 multiplied by t2. So t minus 2 plus 2 again gets cancelled out. So dimensions are L1. So dimensions of this term s ut and half 80 square, they are same. So given equation is dimensionally consistent, I can say. It is dimensionally correct also. Okay, dimensionally correct. We can make that claim. Okay, so this given equation might be correct. So actually you know that this equation is correct because we have been studying this since 9th standard, I guess. So this equation is correct, right? Because we know it from the study of motion. But then if I write similar equation like this, see this one, s is equal to 3 ut plus 580 square. Is this one correct? Tell me.
Correct only, sir.
It is dimensionally, yeah, good. It's not correct. It is dimensionally correct. Okay, but is it applicable in reality? Is it the correct equation to apply in motion? This equation comes in the study of uniformly accelerated motion. Okay, this is called as kinematic equation. No, I cannot call this one as kinematic equation. Okay, so this is incorrect, right? But this is dimensionally correct because dimensions of this term, this term, this term, they match. Okay, so what number is there in the multiplication with any term, that number we can never find out using the dimensions because numbers don't have any dimensions, right? That's why we can say that suppose you come up with some discovery and you have some formula and then it makes sense dimensionally, so you can say that it might be correct. Okay, then you have to do various checks to find out whether it's correct or not, right? All right, so let's move on to the next one, and this one now, s is equal to u square t plus at. So of course this will not be correct, right? And we can check it using dimensions. So I can skip this part, right? Shall I skip this? We just want to check whether it's correct or not. And yeah, we can skip this one. Okay, you can check it. I have written it over here. You can check it. It doesn't, dimensions of this term, this term, this term don't match because here it should be what? Ut plus half at square. Okay, so here I have written extra power of u and extra power of t is dropped. Okay, so instead of 2 I have 1 only. So this is incorrect. So dimensions won't match, right? So that was the first application. Next application is to deduce the relation between different physical quantities. Okay, so for an example, the time period of a pendulum depends on its length and acceleration due to gravity. Find the relation between them, right? So you know the pendulum which oscillates like this. Okay, there is a, of course you have seen a pendulum, right? There is a pendulum clock. Okay, so that pendulum oscillates with certain time period. It takes same time for to complete one oscillation. So that time is called as time period, and they say that this time period depends on what? Depends on the length of pendulum and the acceleration due to gravity. So acceleration due to gravity is denoted by small g. So it is just like any other acceleration. Okay, so how to find the relation between them? So what we do is we write t depends upon. So to say it depends upon, we say it's proportional to. It's proportional to what? It's proportional to length. It's proportional to acceleration due to gravity. But we don't know what power of length and acceleration due to gravity will come in the actual formula, right? To what power it's proportional, we don't know. So we put this a and b. Okay, a and b are unknown. So we say t depends upon length to the power a and g to the power b. Okay, so therefore t will be equal to what? T is equal to some constant. Whenever we drop this proportionality sign and put an equality sign, a constant will enter. Constant means what? It will be a number will enter, right? So that's k. K is a number which doesn't have any dimensions. So t is equal to k l raised to a g raised to b. Then what we do is we take dimensions on left hand side and dimensions on right hand side. So you have t raised to 1, okay, and k doesn't have dimensions. Again you can drop k. Then you have l raised to a, okay, then g, because this is just length, so it is l raised to a only. Then you have g raised to b. So what is g? G is an acceleration. What are dimensions of g? L1 t minus 2, because g is acceleration. Okay, L1 t minus 2 raised to b, right? Then what you do is you multiply this l raised to 1 with this b. So you will have l raised to b t raised to minus 2b here. Okay, then you take together powers of l. Okay, that means so you collect the powers of l. So you have l raised to a, l raised to 1b means l raised to b. So that is l raised to a plus b. Then you have t raised to what? You have t raised to minus 2b. And on left hand side you are only having t raised to 1. Right? So on left hand side you only have t, and on right hand side you are having l raised to a plus b. Yeah, exactly. Very good. So l raised to a plus b and t raised to minus 2b. So the dimensions on left hand side and on right hand side must match, means there is no l on left hand side. That means what you can say is l raised to 0 is there. Okay, because anything raised to 0 is 1, right? So a plus b must be equal to 0. Okay, and there is t raised to 1 on left hand side, and on right hand side you have t raised to minus 2b. So minus 2b must be equal to 1. So a plus b is 0 and minus 2b is 1. You get these two equations, right? So a plus b is 0 and minus 2b is equal to 1. If we solve them, so take that minus 2 on that side, so we get b equals to minus half. Then we substitute that into the first equation, so we get a minus half is equal to 0. Okay, that means a becomes half, a becomes equal to half, right? So we got a and b. We can substitute that in this formula. Okay, in this formula actually, right? So t is some constant k multiplied by l raised to a g raised to b. So what a and b we got? We got l raised to, I mean a is what? Half, and b is what? Minus half. So that is, we have t equals to k l raised to half g raised to minus half, right? Or you can write it as, take that g raised to minus half in denominator, so it can be written as g raised to half. So that is t is equal to k multiplied by l by g raised to half. Okay, and raised to half means what? It's a square root. So t is equal to k square root of l by g. So this is the formula that we can find using the dimensions, and the actual formula is t equals to 2 pi square root of l by g. What does it mean? That constant k is equal to what? 2 pi. Okay, number is 2 pi, and that we can never find out using dimensions. So this thing is clear, how to find out a particular formula. Okay, good. So now this procedure is simple. Okay, this procedure is simple, but it is time consuming. So if there is a question in NEET, right? So for an example, deduce a relation. Suppose time period depends on this one, you know, right? But there would be some questions like something length depends on the universal gravitational constant, okay, the Planck's constant, speed of light, etc., something like that. Okay, and find out the correct relation between them. So there will be 4 options. You have to choose one option. So that question will take time. So what you should do is you should stop for a while. Okay. You should solve other questions first, and then if you have time, then you should attempt that one, because that will take time. In that time you can solve at least 2-3 questions. Okay, if there is a lengthy question like that, right? Okay, we can take multiple examples of this. This one, force in circular motion depends on the mass of an object, velocity, and the radius of the circle. Find the formula relating them. Okay, so let me just explain this, right? Let us just find it out. Okay, so that you will get a clear idea. So then see what is given, that if there is an object moving in a circle, okay, so force acting on that object which is moving in a circle, it depends on the mass of the object, its velocity, and the radius of the circle. It's given. So we don't know what powers of mass, velocity, and radius will come in the formula of force. So that's why we write that force depends upon, so it's proportional to mass to the power A, velocity to the power B, and radius to the power C, right? So then you remove the proportionality sign, you put an equality sign. Okay, so up to this there is nothing difficult, and it is not at all difficult. Okay, even after this. So then you write dimensions on both sides. So on left hand side you have force, on right hand side you don't need to write k. You have mass to the power a, so dimensions of mass is m only, or m raised to 1 to the power a. Then you have velocity. Velocity is L to the power L 1 L1 t minus 1, right? L to the power 1 t to the power minus 1 raised to b you have. And then you have length, radius, so it's L raised to 1 to the power c you have. Okay. Then you can write this thing as dimensions of f. Okay, let me write dimensions of f. So it is m1 L1 t minus 2, and on right hand side what do you have? You have m to the power a only, there is no m in these two terms. Okay, L to the power you have b plus c, right? L to the power b plus c, and t to the power minus b. Okay, that's it. Then we should match dimensions on LHS and RHS. So let's do that. So we got this thing. So if you match dimensions of m, so you get a equals to 1. You match dimensions of L, so b plus c must be equal to 1, right? B plus c is equal to 1, and then you have t raised to minus 2 is minus b, so minus b is equal to minus 2, that means b is equal to 2. You put that here. So if you put that here, what do you get? 2 plus c is equal to 1, so c must be equal to what? Minus 1. Okay, take the 2 on this side, so it's 1 minus 2, so it's minus 1, right? Then you put all this a, b, c in this formula. Okay, so you get f equals to some constant k, m to the power a, which is 1, then v to the power b, b is 2, and c to the power minus 1, sorry, not c to the power, r to the power minus 1, so that is r to the power c, no? So that's minus 1, so it's r raised to minus 1. And then what do you get? So that r raised to minus 1, you can move it in denominator, so you get f is equal to k times mv square by r, right? And the correct formula is f is equal to just mv square by r, and it is called as centripetal force. Okay, centripetal force acting on an object moving in a circle. It is given by mv square by r. Okay, so as we saw, we can't find this k, the constant, the number, we cannot find out using the dimensions. right? This use is clear, everyone? Okay, so now you can see this was a simpler problem. Okay, force depends on mass, velocity and radius. This is simple one. Still it takes some time. I guess it took, I was explaining this also, but still it will take around 1 minute for the simple problem. But if you have other quantities whose dimensions you don't know, right? You don't by heart. Okay, for an example, the universal gravitational constant, it's very difficult to by heart dimensions of every quantity in physics. Okay, so that's why those kind of problems will be, you should on the first page you should avoid them. At the end, if you have time, you should solve them. Okay, that's very simple. Your 4 marks will be definite, but if you chase those 4 marks, maybe you will run out of time and you will lose 8 marks. That should not happen. That's why, right? Okay, then let's come to the next use, to find the conversion factor between units of quantities from different system of units. So personally, I don't find this one more useful. Okay, but anyways, let me explain this. So suppose you have SI system and the unit of force in SI system in Newton. The unit in CGS system is dyne. Okay, so 1 Newton is how many dynes that you want to find out. So 1 Newton is suppose n dynes. Okay, and you want to find out this n. So what you do is, in first system you write length mass time as L suffix 1 m suffix 1 t suffix 1, and in second system you write it as L suffix 2 m suffix 2 t suffix 2. Okay, these are units of length mass time in the two systems of units. Then once you write that, force in first system, you have dimensional formula for force, which is L1 m1 t raised to minus 2. So the Newton can be written as, because the dimensional formula for force is L1 m1 t raised to minus 2. Okay, so its unit must have these dimensions, right? So in the first system it is L1 to the power 1 m1 to the power 1 t 1 to the power minus 2. In second system it is L to the power 1 m to the power 1 t to the power minus 2, right? So this is Newton, this is dyne. So write 1 Newton, which is this thing, L1 to the power 1 m1 to the power 1 t1 to the power minus 2 is equal to n times dyne. Okay, which is L2 to the power 1 m2 to the power 1 and t2 to the power minus 2. Then what we can do is, to find out n, you can just move this thing on other side. Okay, so you get L1 by L2 to the power 1, m1 by m2 to the power 1 and t1 by t2 to the power minus 2 if you move this thing on this side. Okay, and then you substitute what is L1. So m is unit of length in the first system, that is SI system, is meter, and unit in CGS is centimeter. Unit of length in CGS is centimeter, right? Then unit of mass is what? It's kg. Okay, unit in the other system, CGS system, CGS is what? It is centimeter, gram and second, so it's gram. Okay, then you have second which gets cancelled out. Unit of time is equal. Then 1 kg is how many grams? It's 1000 grams. 1 meter is how many centimeters? Is 100 centimeters. So you put that. So then that centimeter will get cancelled out, right? Here the gram will get cancelled out, and you will get 100 raised to 1, 1000 raised to 1, and then if you multiply it out, it is 10 raised to 2 multiplied by 1000 is 10 raised to 3. So it is 10 raised to 2 plus 3 means 10 raised to 5, right? So 1 Newton is 10 raised to 5 dyne. This thing is clear, everyone? Right, good. So then Now we can do it very easily. We don't need to do all this business. 1 Newton is n dyne. So instead of writing it that way, instead of doing all this business, we can just say 1 Newton is what? It is length raised to 1, mass raised to 1 and time raised to minus 2, no? So it's kg meter per second square. 1 Newton is kg meter per second square. And in CGS, it will be just gram centimeter second raised to minus 2. Okay? This thing is clear? Yes, no? Right? So the second square or second raised to minus 2, second raised to minus 2 gets cancelled out. Then here itself you write this is 1000 gram. Okay? 1 kg is 1000 gram, 1 meter is 100 centimeter, and you cancelled out this thing. Gram gets cancelled out, centimeter gets cancelled out, and here itself you get n equals to 10 raised to 5, and you got it, right? So no need to use dimensions. Actually, in doing this also we use dimensions because we wrote the unit in proper form, right? But there is no need to do all this business. That's what I am saying. This thing is clear? Okay, very good. So then let's see some problems based upon this. Okay, so let's see this one. The physical quantity that has same dimensional formula as pressure is. So can somebody tell me what is pressure? It is perpendicular force per unit area.
Upon area.
Very good. So it is force upon area. Yeah, good, Vishalini. Force upon area. So coefficient of viscosity. Do you know about this? Yeah, pressure is force upon area. Good. Coefficient of viscosity. This question is from 2022, a recent question. Okay, so you might not know. Let me tell you, there is Stokes' law of viscosity. The viscous force, it is the friction in the fluids. Fluid means liquid. Okay, it's given by 6 pi eta RV. Okay, so this is force acting on, suppose a ball is moving in a fluid, a liquid, force acting on that, F is equal to 6 pi eta RV. This is Stokes' law. So there you have eta. Eta is called as the coefficient of viscosity. Okay, so this is coefficient of viscosity. R is the radius and V is the velocity, right? So its dimensions are, okay, so we can find out its dimensions, okay, using this formula. Good. Then you have force. So then you have momentum, and then you have Young's modulus of elasticity. So Young's modulus is the ratio of stress to strain. Now this is little bit difficult. I mean, what is difficult? To explain this thing, because we are just starting this chapter and the formulae from all over the physics will come in this chapter only, okay, because we are studying dimensions, right? So we need to know the dimensions of each and every quantity, sorry, the formulae of each and every quantity, right? So Young's modulus is given by stress by strain. And what is stress? Stress is force by area. Okay, suppose you have a wire like this, some wire like this, and you apply some mass. Okay, so you hang some mass. What will happen? Its length will increase. So suppose L was the original length, L is the original length, okay, and the increment is delta L. So strain is, yeah, strain has no unit. So strain is delta L by L. Okay, delta L by L. It has no unit because this unit of length and length will get cancelled out. So unit of this thing is just same as that of unit of force by area. Okay. So unit wise, you can say dimensions of Young's modulus are same as that of dimensions of force by area. So that is dimensions of this thing are same as that of dimensions of pressure, because pressure is force by area. Okay, so if you just look at all of the options, okay, if you just glance over, not stare, okay, glance over all of the options first before solving for dimensions of this one, dimensions of this one, then you will come to know that dimensions of this one are same as that of dimensions of pressure. Okay, and if you have sufficient practice, then you will immediately click this one, right? So this one very, very simple. This thing is clear, everyone? Okay, good. Let's see another question. Dimensions of this thing, m l t raised to minus 2 a raised to minus 2 belongs to the self inductance, magnetic permeability, electric permittivity, magnetic flux. Now this thing we need to check. Okay, so does anybody know? It's option B. Okay, let's check. Okay, so you know all of the dimensions? I don't remember. Okay, anyways, no problem. If you can remember, that's very, very good. If you can remember dimensions of all quantities, very good for you. Then these kind of questions won't take any time for you, right? So let's take self inductance, first one. So we have Faraday's law. EMF induced is equal to L di by dt. Okay, this is the Faraday's law. So current is fundamental quantity, time is fundamental quantity, right? EMF is not a fundamental quantity. So what can you write for EMF? EMF is work done per unit charge. Okay, because I want to relate them. So it is L into di by dt. So I can just say this L is not length, this is self inductance. Okay, its dimensions I want to find out. Times here I have I and T. I can just move these things on other side and I can find out dimensions of L. Okay, so it will be work done, dimensions of work done times dimensions of time divided by I have Q, which is charge, multiplied by current. Okay, so L will be equal to, what are dimensions of work done? That I remember, it is L2 m1 t raised to minus 2. Okay, then you have t raised to 1. Okay, you found m1 L2 t minus 2 a minus 2. Good. Yeah, so t1, so in denominator Q, charge can be written as what? Current is charged by time, so this thing can be written as current into time, and then you have current. Okay, so dimensions of this thing is a. Okay, so what do we get? This time and this time gets cancelled out, L2 m1. Okay, and we got rid of this time and time, t minus 2, and this is current, dimensions are a. So you take that to the numerator, a raised to minus 2. So that's what you got, right? But this L on left hand side and L on right hand side is different. This is self inductance. Okay, who told me answer? Indusha, was it the same thing?
No, sir.
Oh, so you don't remember correctly. Anyways, no problem. Next one is magnetic permeability. Okay, so you should know a formula for magnetic permeability. Okay, so for an example, where will this formula come? Magnetic permeability. There are lots of formulae. F is equal to ILB. Okay, I will use this one, or I can, yeah, force is equal to ILB, and B I can say is, this is force acting on a conductor which is placed in magnetic field B. Okay, I is the current, right? So then B is I can say mu naught Ni, number of turns per unit length, and you have I. So from this one I can find out the formula for mu naught. Okay, so let's see whether it does whether this one matches. Okay, so here you have length and you have length, so this thing gets cancelled out, I guess. Okay, and then what's there? I means a square is there. Number of turns doesn't have any unit, so you have mu naught divided by this is I square, and on other side it will become a raised to minus 2, right? Okay, so force is equal to L1 m1 t minus 2. Okay, and this thing is I, and I means dimensions are a, that is a square on this side, on other side it will be a raised to minus 2, so that is a raised to minus 2, and that are dimensions of mu naught. Okay, so are they matching? m1 L1 t minus 2 a minus 2, right? They are matching. Okay, so this is how we can find out if we don't remember, and if we remember, then this question won't take any time, right? This thing is clear? Yes, no? Okay, all right. If we don't remember, these kind of questions are time consuming. If we remember the dimensions, okay, these are dimensions of magnetic permeability, then it's just not even 10 seconds. Okay, let's see next one. Plane angle and solid angle have. So this is a good question. Dimensions but no units and no dimensions, both units and dimensions, units but no dimensions. What's the answer? It's option D. Okay, we have seen they have units. Okay, we have assigned units to them even though they don't have any dimensions. So they have units but they don't have dimensions. Good. Then the next one, yeah, units but no dimensions. Very good. Unit is radian. Okay, unit for the plane angle is radian, for solid angle it is st-radian. Okay, next one, match list 1 with list 2. Okay, tell me, choose the correct answer from the options given below. So there are dimensions, okay, quantities are given on left hand side, dimensions given on right hand side. So here also we need to know the formulae, right? The gravitational constant we just found. What were the dimensions? I guess this thing, m minus 1 L3 t minus 2. These are the dimensions of G, right? Yeah. So then next is gravitational intensity. Okay, so gravitational intensity is just, gravitational intensity means your small g only. Okay, so what are the dimensions? Small g means what? Acceleration only. Acceleration due to gravity is gravitational intensity. What are the dimensions? Tell me. We'll talk about that, right, when the gravitation comes. Is it D option? Okay, you told the option directly. Okay, I wanted dimensions of this thing. It is this thing, right? It is acceleration, and that's why dimensions are this thing. Okay, then you have gravitational potential energy. So any form of energy will have same dimensions. So that is m1 L2 t minus 2. m1 L2 t minus 2, it's option 4. So dimensions are this thing, potential energy. Let's write this thing as U. Okay, or actually we should have written O. All right, so this 2 is what? It's option A. Okay, this thing is option D, and this one is what? Potential energy, no? So it is B, and the remaining one, so this thing we don't need to check. Okay, L2 T2 is option C. So which one is correct? So A is 2, B is 4. Is it correct? A is 2, B is 4. That's correct. C is 1, C is 1. Yeah. So option A is correct. Yeah, very good. So option A is correct. So this is clear,
Yes, sir.
right? So this is also from 2022. Okay, and this is a good question. Let's see another one. Yeah, let's see another one. Displacement of an oscillating particle is given by y is equal to a sine of bx plus ct plus d. The dimensional formula for ABCD is, tell me. The dimensional formula for ABCD is. Okay, so see, you have y equal to a sine of this thing. Okay, so y is the displacement, means now sine of an angle, yeah, sine of an angle will have no dimensions. Okay, it will be just a number, so numbers don't have dimensions. Then you have a, so this thing doesn't have dimensions, that means dimensions of a are same as that of dimensions of y, right? Dimensions of a and y would be equal. So what is y? It's displacement. So a has dimensions of displacement. Then the sine of an angle, so angle doesn't have any dimensions, right? We just saw angle doesn't have any dimensions. So therefore all these terms, three terms, bx, ct and d, they don't have any dimensions. So you can say that dimensions of bx, it doesn't have any dimension, means you can write this thing as anything raised to 0, right? And anything raised to 0 means what? 1. Okay, so you move that x on other side. Dimensions of b would be equal to what? 1 by x. So 1 by x means x is length. Okay, x is length, so this is 1 by l, that means dimensions of b are l raised to minus 1. Similarly, ct, dimensions of ct are also equal to 1. Okay, because this is an angle, angle doesn't have a dimension, means you can just say it's equal to some number. Okay, means 1. Then you can move the c on other side, sorry, t on other side, so it will be 1 by t. Okay, 1 by t means dimensions of c will be equal to 1 by t, that's t raised to minus 1. And what about d? D is dimensionless. Okay, d is dimensionless, means it's just a number, right? Because it's an angle. Okay, so what do we get then? If we multiply a, b, c, d, so a, b, c, d, if you multiply their dimensions, so a has dimensions of length, b has dimensions of 1 by length, okay, or l raised to minus 1, c has dimensions of t raised to minus 1, and d is dimensionless, that means you can say it's 1. Okay, so l minus 1 and l plus 1 gets cancelled out, it is t raised to minus 1, that's it. T raised to minus 1 is the answer. So it is option B, right? T raised to minus 1 means everything else is 0. This thing is clear, everyone?
Sir, how did you take that A equal to L?
How did I take a equal to L? See, y is equal to a multiplied by this thing, sine of this bracket. Okay, that means what is there inside the bracket? It's sine of something, means the term inside the bracket is an angle. Okay, so sine of an angle is pure number, it doesn't have any dimensions. So y is equal to a multiplied by this dimensionless quantity, right? So you forget about this thing. So y will be what? Dimensions of y will be equal to dimensions of a, right? And what is y? It is displacement, means dimensions of y is same as that of dimensions of displacement, it's length. Okay, and therefore dimensions of a is also same.
Thank you, sir.
Welcome. Now let us solve some more problems based upon dimensional analysis. So let's see this one. The if C be the capacitance and V be the electric potential, then the dimensional formula for CV square is, dimensional formula of CV square is, who can tell me? Anyone? Okay, so now again here we need to know the formulae, right? So if we know this formula, that potential energy of a capacitor is given by half CV square. Okay, then immediately we know that dimensions of CV square are same as that of dimensions of energy, right? So what are dimensions of energy? M1 L2 T minus 2. These are the dimensions. That's it. So which one is correct? M1 L2 T minus 2, and A will be equal to 0, right? M1 L2 T minus 2. So it is option A only. This is clear? Okay, good. Let's see next one. If E and G respectively denote energy and gravitational constant, then E by G has dimensions of. So here of course we need to know the dimensions of energy, and then you have gravitational constant. Okay, so if you know the dimensions of gravitational constant, it will be very easy to solve, right? If you remember all of the dimensions as we discussed yesterday, okay, it will be very easy to solve. Otherwise what can we do? Still this thing can be done faster. So E is energy. Energy can be written as what? You can write it as force into displacement. Okay, work done is equal to energy, you can say. It can be written as force into displacement, and you have formula for gravitational constant. The gravitational force is given by G into M1 M2 by R square. Yeah, so what you can do is G can be written as FR square by M1 M2. So what is M1 M2? You can say M square. So you just divide this thing by this thing. Okay, so let's divide this thing by this thing. So what do we get? We want E by G, no? So F, R and the square gets cancelled. This M square goes to the numerator. That means it is M to the power 2 in the numerator, and in denominator you have R. That's it. Okay, so it is M to the power 2 in numerator. In denominator you have distance. Distance means length to the power 1. If you take it to the numerator, it becomes M2 L raised to minus 1. Okay, so that's the answer. It is option B, right? Very, very simple. Okay, this one is clear?
Yes, sir.
Good. Alright, then let's see next one. If force, acceleration and time are chosen as fundamental physical quantities, find the dimensions of energy. This is the question. So once again, now see, you have the formula connecting energy and force, right? Okay, so ideally what you have to do is, energy depends on force. Okay, it depends on acceleration. Acceleration is, they are writing it as capital A. Then time, so it is F to the power A to the power B, time to the power C, right? And we know that this is a time consuming process. Okay, then we remove the proportionality sign, or directly we write energy is equal to some number, some constant, times F raised to A raised to B and T raised to C, and then we find out ABC. So this is a time consuming process. We will not go into that, right? So what we will do is, we know this formula, we want relation of energy with force. A is acceleration and time. So what we will do is, we know this energy is equal to force multiplied by displacement, right? Force into displacement. Let's write D for displacement. Okay, so F is already there in this formula. That means we need to represent D in terms of acceleration and time. So what is acceleration? Acceleration is, what are dimensions? L1 T raised to minus 2, and out of that you want only L1, right? Out of that we want only L1. So we need to get rid of this t raised to minus 2. So how can we do that? So if we multiply a times t raised to 2, okay, they are writing it as capital T only. So if we do a times t raised to 2, then it will be equal to, its dimensions will be equal to L1 t to the power minus 2 t to the power plus 2. So this thing gets cancelled, right? And we get L raised to 1. That's what we wanted. So energy becomes F multiplied by A t to the power 2. This is our answer. Okay, so what is the value of A, B, C? A is 1, B is also 1, and C is 2, right? So this is the answer, F1 A1 t to the power 2. Okay, that's option C. Yeah, good. So this is clear. I'm sorry. Okay, it's very good. So we should use this kind of simple process. Okay, we shouldn't do this thing because it is time consuming. Okay, we should avoid it as much as possible. Alright, let's see next one. This is good question. Okay, let's check the years here. This was from 2021. This is also from 2021. Okay, this is from 2020. Dimensions of stress are. So we know what is stress. Anybody we saw yesterday? Force by area, right? So what are the dimensions? Dimensions of force divided by dimensions of area. So it is L1 m1 t minus 2 divided by dimensions of area, right? This force is stress is what? Force by area. So area is L to the power 2. Take this thing will get cancelled out, right? There will be L raised to 1 in the denominator. Take it to the numerator, it becomes L raised to minus 1. So that is L to the power minus 1, m to the power 1, and t to the power minus 2. So m1 L minus 1 t minus 2, option C. This is the answer, right? Very good, Pawarna and Diveshwani. Okay, so this is very simple, right? Okay, then let's see next one. If force, velocity and time are taken as fundamental units, is it repeated? Then dimensions of mass are, that was force, velocity, it wasn't even velocity. Okay, if force, velocity and time are taken as fundamental units, then dimensions of mass are. Tell me, what will you do? Force, velocity and time. So force, you want mass, no, mass in terms of force, velocity and time. Okay, there will be some A, B, C, right? So force can be written as what? Force can be written as, okay, it's option D, F v to the power minus 1 t. Let's check. Who said this? Yamini? Who was that? Yamini, Indusha? Okay, somebody said option D. Let's check. Alright, so force can be written as what? It is mass into acceleration, right? And you just want mass. On left hand side you have mass only, and force is mass into acceleration, and acceleration can be written as what? V by t. Okay, so this is just force. Okay, I am writing for force only. So this thing is equal to m into v by t, and you need to get rid of this v and t. What should you do? You should divide by v and multiply by t. That's it. Okay, so this thing is force and you are dividing by v, multiplying by t. Okay, so force by v times t. This should be the answer. Yeah, so it is option D. Very good. Okay, somebody said option D. Alright, let's see next one. Planck's constant h, speed of light in vacuum c, and Newton's gravitational constant g are three fundamental constants. Okay, so Planck's constant h and then Newton's gravitational constant G, and speed of light in vacuum C. Which of the following combinations of these has the dimensions of length? So you need to represent these things. L in terms of h, okay, h to the power a something, c to the power b, and g to the power c. Now if we try to do this, it will take very long time. So what we should do is we can write g as we know, fr square divided by m square, right? G can be written as fr square by m square. But do we have f here? We don't have f. So that means what we can do is, there is c is the velocity, right? So we can represent this thing in terms of velocity. So what I will do is, it is fr into r, and what is fr? It's energy. Force into displacement is energy, okay, divided by m square, and therefore energy is equal to, I want to write energy in terms of velocity. So it can be written as half mv square, okay. Then I have r, and in denominator I have m square. Then I don't need half, okay. See, why did I write half mv square? Because I have c here. C is speed, okay. So I want to write this fr in terms of speed, okay. So this m gets cancelled out with this square. So you can say g is equal to v square r by m, okay. Similarly, now Planck's constant has same dimensions as that of angular momentum. This thing you have to remember, Planck's constant and angular momentum. They sometimes ask this question also. Planck's constant has same dimensions as that of, okay. So it is angular momentum, right? So h has same dimensions as that of angular momentum, that is mvr, okay. Angular momentum has dimensions of mvr. It's option A. Let's check. And then you want to find out length in terms of this. So L is h is mvr, okay. I will just say mvr. Then I want length only, right? So I need to get rid of this v. So then I have v square r by m, and I also want to cancel out m, right? I also want to cancel out m. So what I will do is mvr, I will multiply with this thing, v square r by m. I don't have any problem with r because it will just add it up, its square will be there, okay. So then we can just take square root if we want. So here this m gets cancelled out, and you have c, okay. So here I have v cube, which I don't want, that's why I will divide by c cube, okay. So this v cube and c cube, dimensionally it will get cancelled out, and then I have r to the power 2, okay, and whose square root I will take, right. So the answer will be, what is mvr? It is h. What is this thing? V square r by m? It is g, and then I have c cube, so it will be square root of that. This is the answer, right? So it is option A, right? It's option A. This thing is clear? Yes, no? Everyone? Okay. So I guess still we managed to solve it within 1 minute, okay. And I explained and solved, right? So it takes little bit longer time, but if we solve this way, it takes lot of long time actually, okay. So good. Then let's see next one. Again there is, okay, e square by 4 pi epsilon naught. This is from NEET 2017. This is from 2016. All right. A physical quantity of dimension of length that can be formed of c, g and e square by 4 pi epsilon naught, okay. C, g and e square by 4 pi epsilon naught. So now where does this e square by 4 pi epsilon naught come? It comes in the Coulomb's law. Coulomb's law can be written as 1 upon 4 pi epsilon naught e square by r square, okay. So you have e square by 4 pi epsilon naught r square. That means e square by 4 pi epsilon naught can be written as what? It can be written as fr square, okay. and G can also be written as FR square by M square, right? G can be written as FR square by M square, and you have again speed of light, and you want the length again. Okay, you want length again. So what can you do here? So this FR square, we can get rid of FR square and FR square, but is that sufficient? No, we want length only, right? So again what we can do is we can write that FR square, as we did in last problem. This thing can be written as, okay, because we have speed of light, we need to get rid of speed and mass. Okay, there is no problem with length. So FR, 1 FR, F times R is energy. It can be written as half mv square. Let's write mv square times R. Okay, so this thing is mv square times R, and this thing is what? Again 1 FR can be written as mv square. Okay, so this is mv square by R, sorry, mv square times R divided by m square. Okay, and this m gets cancelled out with this square. Okay, and therefore you have v square R by m. Why did we do this? If we wanted to cancel out FR square, we could cancel out by dividing these two. Okay, but we want to cancel out velocity, right? So once again, if you multiply these two, I guess if you multiply this and this, then what will happen? You will have, no, we can't multiply, no? Yeah, we can. If we multiply these two, then m and this divided by m, it will get cancelled out. Okay, so I will multiply e square by 4 pi epsilon naught multiplied by g. So what happens is you have mv square r multiplied by v square r divided by m. Okay, so first I am cancelling m. I am not caring about the velocity because I have velocity c. I have anytime I can divide by any power of velocity, right? I can get rid of that. That's why first I am getting rid of m. I am getting rid of m. Okay, so m gets cancelled out, and then you have v square, that is v to the power 4. You have r square. Okay, so this is equal to v to the power 4 r square. That means now what do you want? You want length only, you want r only. So you will just divide by c to the power 4. So just divide this thing by c to the power 4. So this v to the power 4, c to the power 4 gets cancelled out, and you can take square root of this r square. So the answer is this thing, right? So it will be just r, or length you can say. So it is square root of e square by 4 pi epsilon naught g. It's there in option A, it's there in option, and in denominator you will have c square. Okay, so it's option D, right? This is clear. Yeah, everyone? Okay, good. So we need to employ these kind of small tricks. Okay. All right, let's see next one. Which two of the following 5 physical parameters have same dimensions? Tell me if you know. Energy density, then refractive index. Refractive index doesn't have any dimensions. Dielectric constant, then Young's modulus and magnetic field. Tell me. Okay, let's see energy density. What is energy density? It is energy per unit volume. Okay, that is energy per unit volume. V is volume, okay, not velocity. So it is m1 L2 T minus 2 divided by volume. Volume is what? L3. So what will be the dimensions? m1 L minus 1 T minus 2, right? L to the power 2 minus 3 is minus 1. Then you have Young's modulus. Okay, what are Young's modulus? Young's modulus is force by area. So force by area So you take force is m1 L1 t to the power minus 2 divided by area. So the area is L to the power 2. Take it to the numerator, it becomes minus L1 minus 2. So that is m1 L minus 1 t minus 2. Yeah, it matched, no? Then we don't need to find out dimensions of magnetic field, etc. I also don't remember. Okay, I'll need to use some formula. Anyways, so it is 1 and 3. It's not 3, no, it is 4. 1 and 4. It's option A. This is clear. Okay, good. So now you tell me the pair of quantities having same dimensions is. Yeah, good, Divashivani. Tell me, impulse and surface tension. Do you know what is impulse, what is surface tension? What is impulse? Impulse
Instantaneous force.
Impulse is force multiplied by time. Okay, impulse is force times time. Anyways, surface tension is force per unit length. Okay, surface tension is force per unit length. Let's write S for surface tension. Okay, it is option C. Let's check. Yeah, that's correct. So surface tension is force per unit length. So obviously they don't match. Diveshwani is saying it's option C. Let's check whether it's correct. Work done is force into displacement, and torque is perpendicular distance multiplied by force. Okay, so yes, dimensionally they are same. That is correct. Very good. Okay, this was very simple question. If we know formally, it's very simple. If we don't know, it's very difficult, right? We can't do anything. All right, let's see next one. The dimensions of mu naught epsilon naught to the power minus half r. Okay, maybe you don't know the formula for this. The speed of light is given by 1 by square root of mu naught epsilon naught, but the problem is it will come in electromagnetic waves. Okay, yeah, so it is L1 t raised to minus 1 and raised to half also. Okay, so that is option A only, right? This is clear. Okay, so it is just speed mu naught epsilon naught. It is square root of mu naught epsilon naught, right? But it's 1 upon square root of mu naught epsilon naught. Okay, so that means it is mu naught epsilon naught to the power minus half, this thing. Okay, that's why this is the answer. Right, let's see next one. The dimensions of half of epsilon naught E square, where epsilon naught is permittivity of free space and E is the electric field, is. Tell me, anyone? This is also energy density. Okay, if you find out energy per unit volume of a conductor, okay, which is being charged, or capacitor which is being charged, then it comes out to be equal to, this is energy per unit volume, U by V. U is energy and V is volume. So this is also a direct formula. Okay, so energy is m1 L2 t minus 2 and volume is L cube, so it is m1 L minus 1 and t minus 2, m1 L minus 1 t minus 2, right? It's option B. Very simple. Okay, let's see next one. It's the same one, I guess. Okay, so that's the end of the problems. Okay, So let's begin with errors. Now what is an error? So you perform any measurement if the measured value is greater than or less than the true value of any quantity, then you have done some error, right? So error is the difference between the true value and the measured value of a physical quantity, right? It's the difference between true value and the measured value of a physical quantity. And there are these two types of errors: systematic errors and random errors. Okay, so what are systematic errors? The errors that take place in the same direction, always they are known as systematic errors. Okay, so what does it mean? If it is positive for the first time, in second measurement also it will be positive, in third measurement also it will be positive, it will keep on coming positive, right, in all measurements. That kind of error is known as systematic error. You are doing error systematically. Okay, so that is one type. Second one is random errors. Random errors, sometimes they can be positive, sometimes they can be negative. Okay, so in sign they can change. Sometimes the measured value is greater than the original value, sometimes it can be less than the original value. This is one form in which random errors can happen. And also they can change in magnitude, right? They can change in magnitude also. Like suppose you want to measure my height. Okay, so if you measure my height in centimeters, suppose for an example, suppose it is 142 centimeters, something like that. Okay, don't take it literally, I have not calculated. So suppose somebody measures it and he or she finds that the height is 143 centimeters. Somebody says it's 150 centimeters. Okay, so that is too much change in magnitude, right? But it will not come in the random error. It is systematic error only because it is performed by some person. What is the random error? So for an example, suppose you are doing some experiment. For an example, you are measuring resistance of a wire. Okay, so you know the Ohm's law, V is equal to R into I, right? You want to measure resistance of a wire. Then what happens? There are certain fluctuations in the voltage, okay, because of which the current will change, right? Suppose there are some fluctuations in voltage. You have applied some voltage and according to you that voltage, the applied voltage is constant, right? So you are taking some value of voltage and suppose all of a sudden there is some fluctuation. Okay, so then what will happen? The current will change and you will not know that there is change in voltage. So this is happening randomly. Okay, it's not in your hand, right? Or you can take another example. For an example, you are measuring speed of a pendulum, not speed, time period of a pendulum, and some wind is blowing in, sometimes it is blowing in this direction, then it is blowing in this direction. Okay, so what will happen? It will change the time period, right? So there is formula for time period. Okay, so it is 2 pi square root of L by G, and because of wind there will be extra acceleration. Okay, and that is, you might know that there is a wind, but you don't have any apparatus to measure the force exerted by wind, etc. So there will be some small error in the measurement of time period, right? Okay, so that is random, that is act of God, right? Natural calamity, you can't do anything regarding that. But systematic errors can be minimized, okay, or they can be corrected. How? So systematic errors are majorly or of these two types. One is instrumental error, one is personal error. So what is an instrumental error? Error in an instrument. Okay, so for an example, zero error. Okay, so what is a zero error? So suppose you take you want to measure current in some circuit, okay, and your ammeter, when there is no current flowing in the circuit also, it shows 1 milliampere. Then what will be the value when there is actually 5 milliamperes of current flowing in the circuit? What will be the value shown by the ammeter? It will show 6 milliamperes. When it is 10 milliamperes actual current flowing in the circuit, it will show what? 11 milliamperes, right? Very good, it will show 11. So each time it is showing 1 milliampere extra. So this kind of error is known as zero error. This kind of error is known as what? Zero error. So what should you do? You should subtract this zero error from all of the readings, okay, all of the measurements, to get the actual measurement, right? So this can be minimized, and it is systematic. That means for the first time, I mean when there is no current flowing in the circuit, it shows positive error. Every time it will show positive error only, and magnitude wise also it will be same, okay. So this is clear why this is systematic, okay. Then there is personal error. So what is a personal error? So personal error, for an example, you want to measure a length of a desk, okay, you want to measure length of a desk, and you have some scale, and suppose you put left end of the scale at left end of the desk, and then you stretch your scale, okay, the rolling scale is there, no, you stretch that, okay, till the another end, and you see like this, okay, what's the length, let me check, okay, or some, this is the habit, right? Some people they will see like this, some people they will see like this from this side, okay. So this is not correct way to measure the length, right? So for these people who are seeing from the left side, for them the reading will be little bit more. For the people who are seeing from right hand side, reading will be little bit less. You have to see at right angles, okay. So this is an example of personal error, right? So the person doesn't know how to take reading, so the person has to be taught that you have to look at right angles to the scale, right? So this is a personal error, okay. All right, so this is habit, this might be habit of a person also, okay. So they have to be taught. And once again, now there might be somebody like, okay, there may be somebody who sees once from this side, okay, at the second time from this side, right? So you can't do anything about them, right? But most of the people, they will have habit of seeing from left, or either from left or from right. So for them it can be corrected, right? And for them each time the error will happen. If it is positive, each time it will be positive. If it is negative, each time it will be negative. This is clear? Yes, no? That's why it is systematic error. This is clear? Okay, everyone? Good. So then next let's discuss accuracy and precision. What is the accuracy? So in normal English, in our day-to-day language, accuracy and precision, they are the same thing, but in physics or in measurement they are different. What is an accuracy? Okay, accuracy is the closeness between the true value and measured value of a quantity. Okay, closeness between the true value and measured value of a quantity, right? So the measure of how close the measured value is to the true value of a quantity, that's accuracy. And what is a precision? Precision is to what resolution the quantity is measured. For an example, suppose true value of length is 15.71 centimeter, it's given to you, okay. Suppose you measure length of this pen and somebody tells you that it is 15.71 centimeter, or it is written on the specifications, okay, right? in the box of this pen. Okay, it's 15.71 centimeters. It's written, that is true value. Now you take three different measurements. Somebody measures it with some instrument and he says that it's 15.7 centimeters. Okay, then somebody measures using some other instrument, he says that no, it's 15.65 centimeters, and somebody measures with some another instrument, he says that no, it's 15.565 centimeters. So which of these is correct? Which of these is more accurate? Tell me, which is closest one? Yeah, right, L1 is closest, right? This is closest, no? There is only 0.1 difference here, right? So here also there will be 0.6 difference in L2. So L1 is closest, 1 is closest, right? But then what is the precision? So precision is the resolution. Resolution means after decimal points how many digits are there. Okay, so see, these instruments are different, they are not same instrument. First instrument can take reading up to what? 0.1 centimeter. That's its minimum reading. Okay, minimum reading is called as least count. So that's your normal scale. Okay, your normal scale has reading in millimeters, no? Okay, 1 millimeter, 2 millimeter, 3 millimeter, right? Yes, no? 10 mm is 1 centimeter. So this is your normal scale. Okay, then you might have seen there are other scales which is known as vernier scale. Okay, so vernier scale gives the reading which is more resolved. More resolved means in more detail compared to the normal scale, right? Then there is screw gauge, but now you won't measure the length of the pen with screw gauge, you can't measure that. But suppose there is some other instrument which gives you even more detailed reading, right? So this is more precise, this is with more precision. Precision tells you what? The resolution of an instrument. This instrument can take reading up to what? Its minimum reading is 0.1 centimeter only. The minimum reading of this one is 0.01 centimeter only. So this is more resolved. Okay, this is more resolved. This one is for minimum reading. Minimum reading for this one is 0.001 centimeter. So it is even more resolved. Okay, and generally the more resolved is the instrument, more accurate reading you will get. But here in these values, this one is more accurate, okay, and this one is more precise. This one is more accurate, this one is more precise. This thing is clear, everyone?
Clear, sir.
Right? Okay, in physics the accuracy and precision are different things. But generally you have better instrument, more precise instrument, and you know the correct technique, then your reading will be more accurate also. Okay, so this thing doesn't mean you shouldn't have a better instrument, right? Any doubt in this, Indusha? Anybody?
No, sir, clear.
Okay, good. So this is accuracy and precision. These are some definitions regarding error. Now let's move on to the measurement of errors. How to measure the errors. So let's see what is an absolute error, relative error, and percentage error. Suppose you want to measure some quantity. Let's again consider the length of this pen. Okay, and it is given to n number of people, n number of students, suppose in this class, and they measure lengths L1, L2, okay, up to Ln. These are the measurements. And suppose I don't know what is the true value, then what I will do is I will find out the mean of all these readings. Okay, so length measured by Indusha, length measured by Selva Kumar, okay, that's L1, L2, so on and so forth, up to Ln is suppose length measured by Nikita, and I will add it up and divide by n. So this is the mean value, right? This is how we take mean. Mean means average. This is the average value, right? So now we will consider this mean value as the true value of this quantity. Okay, we will say that this is the true value of the quantity, So what will be error in the first measurement? So error in first measurement is, suppose delta L1, it is L1 minus this mean value. Error in the second one is delta L2, it is L2 minus Lm. So on and so forth. Error in the nth measurement will be equal to Ln minus Lm, right? So this is how we find out the errors. But now sometimes the error might be positive, sometimes they might be negative, okay? And it might happen that suppose you want to find out the average of these errors, okay? So if you add, suppose for an example, L1 is delta L1 is 0.1 centimeter and delta L2 is minus 0.1 centimeter, then delta L3 is minus 0.2 centimeter, okay, and some other reading is plus 0.2 centimeter, and you want to find out the average error. If you add it up and divide by n, what will happen? There are chances that it will come out to be equal to 0, right? But does that mean that on an average you are performing 0 error? No, right? So what we do is we take absolute value of the error, okay? Sometimes the error will be positive, sometimes the error is negative, and we are not biased. Positive error is also error, negative error is also error. So what we do is we take absolute value of the error, right? So absolute error is represented like this. This is the absolute value symbol, right? You know that, okay? So in nth measurement, in any measurement, in L1, suppose the absolute error would be like this, okay? It will be represented by this absolute value symbol, 2 lines, okay? What does that mean? Even if the error is negative, suppose delta L1 is minus 0.1, still the answer of this thing would be what? It's 0.1, okay? So we get rid of the negative sign. Then we find out the mean absolute error. What will be the mean absolute error? Just take absolute errors in all quantities, okay? Sorry, in all measurements. Quantity is same, measurements are different. Just take absolute errors in all measurements, add it up, okay, and divide by number of measurements, okay? Divide by number of measurements. So you get the mean absolute error, okay? So this is the mean absolute error. So now the chances are that the measured value of your quantity will be plus minus, measured value will be in between Lm minus delta Lm, okay, and Lm plus delta Lm, right? The measured value is, suppose L, it might lie in between what? Lm, the mean value of quantity, minus the mean error, and the mean value of quantity plus the mean error. This thing is clear? Yes, no? Okay, unless you are taking very biased measurement, right? Okay, so the measured value of a quantity generally lies between Lm minus delta Lm and Lm plus delta Lm. Alright, so this is the mean absolute error. The next is the relative error. So just take mean absolute error, divide it by the mean value of a quantity, you get the relative error. Okay, so mean absolute error in length is delta Lm, mean value of length is Lm. So delta Lm divided by Lm is the relative error. Very simple. The next is the percentage error. Just multiply relative error by 100 and you get the percentage error. Okay, that is percentage error. So any confusion in these definitions?
No, sir.
Okay, everybody?
No, sir.
Good. Let's see after that. So these are error in one measurement. One measurement means not one measurement, error in the measurement of one quantity, right? Now suppose you want to measure two quantities, okay, and you want to find out error in the combination of those two quantities, right? So because sometimes you need to add quantities, sometimes you need to subtract, sometimes you need to multiply, okay. I'm sorry. For an example, you want to find out perimeter of a rectangle. So do you know what is the perimeter of a rectangle? Suppose this is a rectangle, you want to find out perimeter. So perimeter is total area of the boundary, right? So this is length and breadth. So perimeter would be equal to what? It is 2 times of L plus B into 2. Very good. So it will be 2 times of L plus B. So you will measure length, you will measure breadth of the rectangle, and you will add it up and multiply by 2. That is the perimeter. Then another example is you want to find out semi perimeter. So semi perimeter is just half of the perimeter, it's L plus B. So here you need to add up the two quantities, right? You need to add up the length and the breadth. So for length you will take separate measurements, okay. For breadth you will take separate measurements, right? And then there might be n measurements for length, there might be n measurements for breadth. Then you will find out the true value of length, you will take mean of all those measurements, right? And you will find out mean absolute error, okay, in length. You will find out mean absolute error in breadth. So what will be the mean absolute error in the semi perimeter? That's the question. So this is like a common sense only. The mean absolute error will be added up because you are adding the two quantities. Okay, this thing is clear? Yes, no? Okay. So in case of addition and also in case of subtraction, what happens is the mean absolute error gets added up, okay. So suppose you can take C is equal to A plus B, right? A is one quantity and delta A is error in A, B is one quantity, another quantity, delta B is error in B, and suppose C is equal to A plus B, okay. So now see, measured values can be written like this. So A dash is the measured value of A, it will be A plus minus delta A. B dash is the measured value of B, it can be written as B plus minus delta B, okay. So what does this mean? This is the mean value of A and this is possible error plus or minus delta A, okay. This is the mean absolute error possibly, okay. So as we said, the value lies between what? The measured value of a quantity lies between mean value minus the mean error and mean value plus the mean error, okay. That's why we write it like this. So it is A plus minus the mean error, right? Then similarly measured value of B will be B plus minus delta B. Then suppose C is equal to A plus B, what would be the measured value of C? Let's call it C dash. C dash will be equal to A dash plus B dash. Then what you do is you write C dash as C plus minus delta C, and you put A dash is A plus minus delta A, B dash is B plus minus delta B. Then what you do is you just cancel out the C with A plus B, right, because that's what it is. C is equal to A plus B, and then you get plus minus delta C is equal to plus minus delta A plus minus delta B, okay. And therefore what is delta C? It is delta A plus delta B, right. So now there are various possibilities here. So you can take this plus sign, plus minus sign, minus plus sign, minus sign, right. But now we want to find out what is the maximum possible error in the resultant, and that's why we just add up the errors, we don't take negative signs, okay. Our aim is to find out how maximally our reading can be wrong. What is the maximum possible error? That's what we want to find out. That's why we take just positive sign. Okay, so this is error in the addition. In subtraction, what will happen? So there will be just a negative sign here. Again, the c will get cancelled out because c is a minus b. Here it will be, get cancelled out, and your answer will be plus minus delta a minus plus delta b if you subtract b from a. But still you will take what? Positive sign only, because you want to find out what is the maximum possible error. Okay, is that fine, everyone?
Yes.
Good. All right, so this is an example. As I said, perimeter is written like this, 2 times of L plus B. So what will be error in the measurement of perimeter? It will be 2 times of delta L plus delta B. Okay. All right, next, now we might need to multiply two quantities also sometimes, and we might need to divide them also. So in multiplication or a division, what happens to the error? So for an example, the area of a rectangle is equal to what? The area is length times breadth. So there is some error in length, some error in breadth. What would be the error in area? Okay, so that's what we want to find out. So suppose C is equal to A times B. Okay, so therefore C dash, these are what? The absolute values. Okay, I mean the mean values of A and B, two quantities. So C is some other quantity. For an example, area is equal to what? Length times breadth, one quantity multiplied by second quantity. Then the measured value of that area or the resultant quantity would be what? Measured value of A multiplied by measured value of B. Very simple, right? So again we put C dash is equal to what? C plus minus delta C. A dash is equal to A plus minus delta A. B dash is equal to B plus minus delta B. Okay, then you expand this. So then these four terms will come. Out of that, first term will be A times B. So A times B is what? It is just equal to C. You cancel out that C with A times B. Then what do you get? Plus minus delta C is equal to plus minus of A delta B plus minus delta A times B plus minus delta A delta B, and out of these, this quantity would be very small, delta A times delta B. Okay, so if I want to tell you an example, suppose this is the length, this is the real length of the rectangle, and this much is the error. This is still very big error. Okay, suppose this is some error. This is the breadth, right, and this much is the error in breadth. So actual area would be this much, right? This much would be the actual area. Okay, and this is the extra area that you are measuring. Out of that, this is delta L. If you see this is delta L, right, and this thing is delta B. So what is delta L times delta B? It is just this small, this one, okay, this small rectangle. This is delta L times delta B, right? It's very small. This thing is clear? Okay, so that's why I'm saying that this delta A times delta B would be very small. Okay, then what we do is we divide this whole thing by A times B. Okay, so we get this plus minus delta C divided by AB, or you have C, AB is equal to C, right? And here also on right hand side you divide it by AB everywhere, and then this quantity which was already very small, now you are dividing by AB. AB is the area. Okay, so what you are dividing, you are dividing this thing by this whole area. Okay, so this thing was already very small, you are dividing it by this complete quantity. Okay, I mean this complete area, right? So that the division or this quotient, it would be very small. So we get rid of this, we just neglect this one. Okay, then here A and A will get cancelled out, so you have plus minus delta B divided by B. Okay, and what is left in this term? so b and b gets cancelled out, so you have plus minus of a divided by a. So finally you get delta c by abc, so delta c by c. Okay, so this is the result, sorry, this is the relative error in the resultant. It is delta a by a and plus you have delta b by b. So if you multiply two quantities, then what happens is error in the resultant is what? Just relative error in the resultant is sum of relative errors in the two quantities. Okay, this is the result. Even if you have c equals to a by b, then also the relative error in the resultant, that is c, will be equal to relative error in a plus relative error in b. Okay, so this one I am not explaining, it's lengthy, okay, but it's similar, right? So we just need to remember, in case of the multiplication or a division, what happens is relative errors are added up. This is clear, everyone?
Clear, sir.
Okay. Okay, good. Next, error of a power. Okay, suppose you know that if c is equal to a times b, then what happens to the relative error? It is delta a upon a plus delta a and delta b upon b. Now suppose c is equal to a square, so this is still, I can write this thing as a times a, right? I can write this thing as a times a. So what will be error in this one? Delta c by c will be equal to delta a by a. Okay, error, relative error in first quantity plus the relative error in second quantity, that is also delta a by a. So if c is equal to a square, then delta c by c will be equal to what? 2 times of delta a divided by a. This is clear? Yes, no? Okay, very good. So then if you have c equals to a cube, that is a times a times a, 3 times, right? You are 3 times multiplying a, then what will be delta c by c? It will be 3 times of delta a by a, right? And if you have c equals to a raised to n, then you have delta c by c will be equal to n times of delta a by a. Very, very simple. Right? Very good. And then you have a general result like this. So suppose some quantity is a raised to q, b raised to x, c divided by c raised to y, d raised to z. Then what will be the relative error in this quantity? It is just, okay, delta p by p can be written as q times of, okay, q times of, because a is raised to q, okay, q times of delta a by a plus x times of delta b by b plus y times of delta c by c plus z times of delta d by d, right? Okay, very good. So these are the errors. Okay, and then let's see a small topic called as significant figures. So what are significant figures? So significant figures means, suppose you are taking some measurement, you are taking some reading. So in that reading, for example, I measure length of this pen, okay, and I say that it is 15.71 centimeters. I am measuring it using the vernier caliper. Okay, so then in this 15.71, I am very sure about these 3 digits, that it will be 15.7 something. This last digit, it might be +1 -1, right? There can be some error in this one. Okay, for example, if I see from this side, I have calculated little bit extra. If I see from this side, I have calculated little bit less. Okay, or there might be a little bit of sliding of the scale also. By any possibility, there are numerous possibilities, right? So this one, the last digit, can be, it might not be correct, it might be correct also, it might not be correct. Okay, so this last digit is known as error digit. or error bit, you can say error digit. Okay, so what are significant figures? So these four figures means in this reading there are four figures. So all the digits that you are certain about plus first uncertain digit. Okay, or all the figure means numbers, so all the numbers that you are certain about plus one uncertain number. Okay, that is known as the error digit. Okay, so these are significant, these are important. Okay, these are important. This thing is clear? Yes, no? Okay, good. So there are certain rules to find out the significant figures. So all the non-zero digits are significant. If there is a non-zero digit, it is significant, right? If you write a measurement, every non-zero digit is significant. All zeros between two non-zero digits are significant. For an example, in place of 15.71, I write 10.71 centimeters. Suppose this is the length of this pen. So this zero, which is in between two non-zero digits, is significant. Okay, or there are two zeros like this, 100, okay, 0.71, something like this. So this zero is also significant, this zero is also significant. Okay, so the zeros in between non-zero digits are significant, right? That's the second rule. Next rule is all zeros before the first non-zero digit are not at all significant. I can write 100 zeros before this first one or first non-zero digit, and all of them will be insignificant. They are not at all important, right? Okay, for an example, what is the date today? Today it is 20, what's the date? 25, right? Okay, suppose date is 5, okay, 5th of January. So you can write 5th of January as 5/1 and it is 2024, right? You can write that thing also as 0501. Okay, some people write it like this, 0501, okay, 24 or 2024. So in this one you write this thing as 5 or 05, it doesn't matter, right? Yes, no? So that 0 is insignificant. So all zeros before the first non-zero digit are not significant, right? Then there is a rule regarding terminal zeros. Terminal means if you write zeros at the end. So terminal zeros in number without a decimal point, okay, this is important, without a decimal point are not significant, but terminal zeros in a number with decimal point are significant. For an example, I say that length of this pen again is 15.70 centimeters, right? So this 0 is significant. Okay, this 0 is significant. Why is it significant? What does it tell you? Why can't I say 15.7 only? Okay, so this is the matter of precision, right? If I say 15.7 centimeter, the reading has been taken with the normal scale, right? Your meter scale, okay, your centimeter scale actually, which you keep in your compass box, okay? And this reading, it can't be taken using the centimeter scale, right? Here the device used is the vernier caliper. This is more precise instrument. So these trailing zeros, if you have decimal point, these trailing zeros tell you about the precision of the instrument. Okay, these trailing zeros tell you about what? The precision of the instrument. This thing is clear? Yes, no?
Yes, sir.
Yeah, so that's why they are important. That's why they are important. They are significant. Okay, very good. Then now we do various calculations. in 40.00 there will be 4, because these trailing zeros are important, right? And the zeros in between any two significant digits are also important. Yeah, that is before decimal point, but 0 in between two significant digits are also significant, no? Right? Good. Then now we do various calculations. For an example, in this calculation you have two readings, okay? So suppose this is the length and this is the breadth of some rectangle. This is the length and this is the width, okay? And you want to find out the semi perimeter, which is length plus breadth, right? So this is clearly taken with one instrument, this is taken with the another instrument. So when you add it up, you will add it up and you will round it up. You will round up the result to the correct number of significant figures. So significant figures in first one are 4 only, okay? And the precision is up to 2 digits after the decimal point, okay? So here also significant figures are 4 only. That's not the problem, but the precision is different, okay? So precision here is up to 3 digits after the decimal point. So we need to round it off, okay? So first we add up and then we round up. I'm sorry. Okay, so you find out the total and then you will round it off to what? The precision of this instrument, okay? Which instrument? Which is least precise out of the two. If there are 5, you will choose least precise out of the 5, right? What would be the result? It is 18.022. You will round it off to 18.02. Okay, so this thing is clear. So if there is a question like this, so write with correct number of significant figures, then this is what we should do. Okay, everyone? All right, very good. So now let's see some problems based upon this thing, and this is from NEET 2023. The errors in measurement which arise due to the unpredictable fluctuations in the temperature and voltage supply are which errors? Yeah, very good. It's option D. Very good, Pawarna. Right? Straightforward. Let's see next one. A metal wire has mass. This is also from 2023. Okay, metal wire has mass of 0.4 plus minus this thing, and radius of 0.3 plus minus 0.001 mm, and the length is this much. Maximum possible percentage error in the measurement of density will nearly be. Tell me. What is density? This is a wire, okay? This is a wire. Mass upon volume. It's mass upon volume, right? So density is mass upon volume, and this is a wire. So what will be its volume? It's area of cross section multiplied by length, right? So that is, what is the area of cross section? It is circular one, so this is pi r square. So it is pi r square, okay? R is the radius multiplied by length, and then the error in mass is given, right? Reading of mass is given with plus minus possible error. Reading of the radius is also given, reading of the length is also given. So just use this formula, delta rho by rho will be equal to what? Or we want percentage, no? So let's multiply by 100. It will be equal to delta m divided by m, pi sorry, pi is a constant, plus it is r raised to 2. So let's take 2 times of delta r by r, plus you have delta L by L, and then you will multiply this thing by 100 because you want to find out percentage error. So what is delta m? This is m, this is delta m, right? 0.002 divided by 4. Okay, and let's multiply out with 100. Okay, plus 2 times of delta r by r. So delta r is 0.001 divided by 0.3 plus delta L by L. Okay, this thing also multiplied by 100. Okay, and the last one is plus 0.02 divided by 5 multiplied by 100. So tell me what's the answer. Calculate and tell me. Anyone? This 0.2. Okay, this will be 0.2 by 4. Again 0.05, I guess.
0.4, sir. First one.
0.4. This one.
Yes, sir. Denominator.
Denominator means it will be, yeah,
0.4, sir, not 4.
0.
0.4, sir, not 4.
Denominator is 0.4. Okay, denominator is 0.4. Right. Thank you. All right, this is 0.4. So then it will be 0.2 divided by 0.4. That means 2 by 4. So it's 0.5. First one is 0.5. Second one is 0.1. Actually 0.2 by 3. Right. 0.2 divided by 0.3. That means it will be 2 by 3. So this thing will be 0.66. And what about this one? So this thing will be 2 by 5. Right, so 2 by 5 means 0.4. 0.4 plus 0.5 plus 0.6. How much is it? 1.6. Is that the answer? So option C. Good. So 1.6 is the answer. Right? Everyone can check. Okay, so that's the answer, right? 1.6. Okay, so this is simple question. Yes, no, it is directly based on this formula, composite error, right? Okay, good. Let's see next one. The percentage error in measurement of G is. So this is not from NEET, this is from some other exam, RS 2022. Anyways, so what will be the percentage error? And now they are so generous, they have given the formula also. In NEET it will not be given, okay, mostly. Okay, so you know that T is equal to 2 pi square root of L by G, and from that first you need to find out the formula. Okay, you need to find out G like this, and then you can use these things, right? Okay, so this exam RS, I don't know what, so they are quite generous, they have given the formula directly. Okay, so you can find it out very easily. So G is equal to 4 pi square L divided by T square, and therefore delta G divided by G is equal to what? Delta L divided by L plus 2 times of delta T divided by T. Very simple. Then just put the values. So what's that? Delta L by L. So delta L is 0.1, L is 10. So 0.1 by 10 plus 2 times of delta T by T. So that is 1 by 100. So that is 0.1 by 10 means 0.01. Okay, but you want percentage error, no? So this thing multiplied by 100. Okay, so this thing multiplied by 100. So let's multiply out with 100 everywhere. So this 100 gets cancelled. 100 by 10 is 10. So 10 times 0.1 is 1, 1 plus 2 is 3. So 3% is the answer, right? Okay, very good. Let's see next one. This is from NEET. The area of a rectangular field in meters square of length 55.3 and breadth 25 after rounding off the value of correct significant digits is. Tell me what will be the area. So length is 55.3 and breadth is 25. So first of all, just multiply and tell me what is the area. Anyone? No, I am just asking, is it option C? Let's check. I am just asking what is the area. 1382.5. Okay, good. 1382.5. Yeah. So now round it off first to correct number of significant digits. How many significant digits are there? In length there are 3. In breadth there are 2, but we want least number of significant digits. Okay, so that is 2. So you need to round it up to 2 digits only. So what will you do? So this is first digit, and second one here itself, what will you do is you will round it up. So see, third one, it's greater than 5, so this digit you will increase by 1. Okay, that's it. So this is 1400, and that point and everything then doesn't matter, 1400, and you can write it as 14 into 10 raised to 2. That's correct, right? So that is very, very simple. Okay, so these trailing zeros now, they are insignificant. Okay, as we learned, in case of decimal point, trailing zeros will be significant, and here if we write a number like this, trailing zeros are not significant, right? Selva Kumar?
Yes, sir.
Good. Let's see next one. Taking into account of the significant figures, what is the value of this thing? 9.99 minus 0.0099. Tell me. So you have 9.99 and you need to subtract 0.0099 out of that. Okay, so just round this off. Okay, so it will be minus 0.01, right? So the answer would be 9.98. That's it. Okay, you can carry out the subtraction and round it off, still the answer will be same, right? So it's option B. Okay, this is also from NEET 2020. So NEET 2020, 2022 significant digits. I'm sorry. And then yeah, 2020, 2022. So these are these questions are designed by NTA, okay, who is currently designing a NEET exam, right? So these are free marks actually. This question you should never leave. These are free marks, right? Let's see next one. The number of significant figures in the numbers, this one and this one. Yeah, tell me. This one and this one. How many significant digits are there? This is very, very simple. It's option B. Yeah, everybody is saying very good. 5 and 7. Good.
5 and 7.
5 and 7. Very good. Okay, so it's option B. Next one, period of oscillation of a simple pendulum in the experiment is recorded as this thing. The average absolute error is, tell me. So now this is simplest of all possible questions, right? But this one is lengthy, that is the problem. Okay, so if you are running out of time, then keep this aside. Okay, if it's in the beginning, if you're doing it fast, do this one. This is sure shot, 4 marks, right? So tell me, what will you do first? So these are n measurements. Okay, what do you need to do is find out their mean. So mean time period is equal to 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80. Okay, and divided by, you have n is equal to 5, I guess, 1 2 3 4 5, right? So you will find out mean. Okay, then how much is that? 2.63, 42, then 7180, I don't know. You need to add it up and divide by 5. Anyone? $13.12, that's addition. Divide that by 5. Or 13.72, divide that by 5, no? $2.624. Okay, so that is 2.62 with significant digits. 2.62. So what is the error in first one? 0.01, right? And we are taking absolute error now, plus error in second one is 0.06, error in third one is 0.20, that's too much. Error in next one is 0.09, and error in the last one is 0.18, and you divide that by 5. So this is how you will find out the mean absolute error, but it takes time, right? So 20 plus 18 20 plus this is 27, that is 47, 47 plus 1 is 48, 48 plus 6 is 48 plus 6 is 54, 54 divided by 5, so that is 108. So 0. Okay, that will be 0.1. Okay, 0.108 it is, and you will round it up, so it will be 0.11, not 1, right? So this is the answer. It's option B. No, it's option B, if my calculation is correct. I'm sorry. Sorry. Okay, actually the error should have same resolution as that of the reading, that's the first rule. Okay, so 0.1 doesn't have, 1.0 doesn't have, so it has to be between this one and this one. So my calculation is 0.108, and I am rounding it up to the same significant digits after the decimal point as that of the readings, so that's why it is 0.11. Somebody check whether this thing is correct. Yes, no? Correct? Good. So then this is the answer. Okay, so here also, now you might be tempted to write this thing, but this is incorrect. Okay, this is incorrect. Why is it incorrect? Because your answer should have same number of significant digits as that of what? As that of the readings, right? Everyone, this is clear? Okay, good. Let's see next one. if voltage V is this thing and current is this thing, the percentage error in the resistance is. Okay, so what is resistance? It's V by I. Now these are kind of repeated questions. So you have delta R by R multiplied by 100, because you want percentage error. It will be just delta V divided by V multiplied by 100 plus delta I by I multiplied by 100. It's very simple, right? So that's 5 by 100 times 100. That's very good. 100 gets cancelled out. Okay, plus 0.2 by 10 into 100, even that is good. So 100 by 10 is 10. 10 times 0.2 is 2. This was 5, that is 2, so 7%. Right, option C. Good, 7%. Very simple. Let's see next one. Okay, you measure two quantities as A equals to this thing, B equals to this thing. We should report the correct value for root AB as. Okay, so there might be question like this. So first of all, find out root AB. So what is A? A is 1.0. What is B? It's 2.0. So what is root AB? So suppose C is equal to root AB. Tell me. Okay, so A is 1.0 and B is 2.0. So multiplication would be what? 2.000, something like that. Am I correct? 2.00, right? But you are taking square root, so it's just square root of 2. So what will be square root of 2? I told you to remember that 1.414, right? That is square root of 2. But then your reading, I mean your measurements, they had only one significant digit after the decimal point, so you need to round it up. Sorry. Okay, so you should round it up to what? 1.4, right? But that is one part only. And then you have delta C by C, because you are multiplying. Okay, this is equal to, C is equal to what? It's AB raised to half square root, right? So it will be equal to half of delta A by A plus half of delta B by B. So that is equal to, tell me, what is delta A? 0.2. So it's half of 0.2 divided by 1 plus half of 0.2. Okay, half I have taken out. 0.2 divided by 2. So what's that? 0.2 by 1. So it's like 1 divided by 0.2 is 5. Right, so 1 by 5. Sorry, 1 divided by 0.2 is what? It's 5. Yeah, so it is 1 by 5. So that is 0.2 only. Oh, what I am. This is 0.2. Alright, 0.2 by 2 is what? This thing is 0.1 only. Okay, so this is 0.2 plus 0.1 is 0.3. So 1 by 2 times 0.3. Okay, and then you have delta C.
100,
Yeah?
right?
No, that you will do when you want to find out the percentage error. Here
Oh,
you are
okay.
just finding out the relative error.
Okay, sir.
Right, take C on that side. So C is 1.4. So this thing multiplied by, sorry, delta C is equal to, take C on that side. So 1.4. So this thing is 1 by 2 of this. This will be 0.15 multiplied by 1 by 1.4, or better way, it's 0.7 multiplied by 0.3. How much is it? 0.27, right? Okay, and still it rounds off to what? 0.3. Yeah, so it is, no, it is 0.27, no? So it will be 0.3, round up, right? So answer would be 1.4 plus minus 0.3. Okay, so it's option C, not D. Right, everyone? This is simple. Yes, no, but there is some process involved in this one, right? Which number to round up to? But that is very simple, no? See how many digits are there in your reading. Okay, here there is one digit after the decimal point, so you need to round off to one digit after the decimal point. That's it.
Sir,
Yeah, tell me.
the delta C is equal to half into 0.3 into 1.4, no, sir?
Delta C is
Half into 0.3 into 1.4, sir.
right.
If we cancel out with 2 means 0.7, sir.
Yeah, 0.7.
Then it will become
Okay,
2.1, no, sir.
right. My mistake. Sorry. It will be 0.21 and this will be 0.2. Okay, very good. Sorry, my mistake. I multiplied 9 with 3. I don't know from where. Okay, then it is 0.02 and then it is what? Option D. So Poorna was correct. Alright, I can do that. You should not. Right? I don't have to write an exam. Alright. But is the process clear, everyone? Okay, good. Let's see next one. In an experiment, the percentage of error occurred in measurements of physical quantities A, B, C and D are this thing 1%, 2%, 3% and 4% respectively. Then the maximum percentage error in the measurement of X, where X is equal to this thing, will be, tell me.
16%, sir.
Is it 16%? Right. Let's see. Delta X by X would be what? 2 times of delta A by A plus, even writing this is not worth, right? We'll just calculate it. Okay, half of delta B by B plus 1/3 of delta C by C plus 3 times of delta D by D, that is equal to 2 times of 1% plus half of 2% plus 1/3 of, okay, that's very good. They have given the values that get cancelled out, plus 3 times of delta D by D is 4%. So this is 2 plus 1 plus 1 plus 12. Yeah, so that is 16%. Okay, so answer is 16%. Right, that's very simple. Option C. Okay, good. Let's see next one. The density of a cube is measured by measuring its mass and length of its sides. If the maximum error in measurement of mass and length are 3% and 2% respectively, maximum error in the measurement of density would be. That is very simple. Density is mass upon volume, and volume of a cube is just L raised to 3, right? So delta rho by rho would be equal to what? And here you want percentage, so multiply by 100. Okay, it's 9. Let's check. So it's equal to delta m by m plus 3 times of delta L by L. Okay, so delta m is 3%. Yeah, this thing multiplied by 100. This thing times 100. This thing times 100. Delta m by m times 100 is 3% plus this is 3 times of 2%. So that is just 3 plus 6, 9%. That's correct. Very good. Okay, it's very, very simple. Okay, let's see this one. All right, good. So first of all, if there is a question like this, get happy. Right? In an experiment, 4 quantities A, B, C and D are measured with percentage error 1%, 2%, 3% and 4%. The quantity P is calculated as follows. The percentage error in P is, tell me. Three times of 1%, 2 times of 2%. Option C, everyone? Good. So it's option C. Alright. So then there are similar kind of questions. Okay. And there are 1 or 2 good questions also. So I will just leave these questions for you. Okay, as a homework, and there will be added homework also.